Okay, we'll get started. Looks like nobody else is joining us. This is a bigger crowd than I was expecting for such a dull topic, but thank you all for being here. So we're going to be talking about distributed tracing in .NET 6. I realize .NET 7 is out, but .NET 6 was when I wrote it, so that's what we're doing. With using a product called, a library called OpenTelemetry. So I'm Martin Thwaites, a developer advocate at a company called Honeycomb, but I am an observability evangelist first. Always was. And you can catch me on Twitter. I normally rant about this kind of stuff on there. So we're going to talk about a few things. We're going to start by explaining a bit about what observability is. We're going to talk a little bit about what OpenTelemetry is, and then we're going to go through a little few bits about how to implement that in .NET. Spoiler, it's really easy. It's like 10 lines of code. So I'm going to try and get at least 40 minutes out of this. But it is very, very simple. We'll talk about a few other concepts around things like the OpenTelemetry collector and how that's useful, and some of the more interesting and scary concepts around OpenTelemetry. Funny story, we were trying to find a picture that kind of embodies what observability is, because it's a wide topic. And this was the best one that we could come up with. The idea of observability is how well can you understand the internal state of your system by the outputs that that system gives. So the idea of a child not knowing what's underneath the rock until they look under the rock, and then they find more rocks, and then they lift up more rocks, and then you put all the rocks back down, put the moss back on. I wasn't the last person to touch it, honest. But that's the idea of observability, is this idea that you can visualize what's happening inside of your system by the outputs that it gives you. So not reaching inside your system and grabbing things out, but having your system output information that you can then do. It's where Honeycomb was formed, which is the company I work for. And it was all about this idea of how do we make people rely on their production observability more than they rely on their debugging? How do we make debugging in production as good as debugging locally? So, what is observability in general? So, Wikipedia defines it like that. It's that internal state. So, asked a couple more people for their ideas on what exactly observability is. So, Charity Majors, our co-founder, who coined the term about 6-ish years ago. It's about unknown unknowns, and we talk a lot about these ideas of what you know and what you don't know, and what you don't know you don't know. And observability is for those unknown unknowns, the things that you don't know. So Paul Bruce, who runs the Olifest, which is a conference like this, specifically around observability, it's about designing our systems to intentionally emit information. So that intentionality of you writing your systems so that they intentionally emit information that you can use to understand that. But it's also about the people who operate your platform, but also the people who rely on your platform. So the people who are maybe your ops team, who are then running that thing in production. So you're actually intentionally emitting information out of it. Now, observability is all about asking questions of your system after it's gone live. Now, we've all done, I would imagine, a production system where something went wrong and you said, it'd be nice if we had this. So you then do another release with some more logging inside of there, and then you went, oh, it doesn't happen anymore, so I've now missed that opportunity. The idea of using observability is that you don't know what you might need to know, so send all the information that you can, and then when something does actually happen, you've got that information to be able to see. So the sorts of things that you might ask of your system, so is this feature being used? Might be an interesting one that you want to see. So this isn't just about debugging. This isn't just about something went wrong. It's all about how can I observe my system and know what's happening in that system in production. But it also goes down to that really sort of core level performance stuff, like what about when things are in two regions? That's something you can't see locally. One's in US East and one's in EU West. One's in, I don't know, somebody come up with another region. And when a request is transitioning there, maybe it's just one request, maybe it's 5 requests, maybe it's 100 requests, but it might be very small, the number of requests. And this is things you don't know until you go into production. You don't know that you want to know. So that's the idea around observability in general. So then we go a little bit further and we start to talk about tracing, or more specifically, distributed tracing. Tracing is this idea of profiling your code. It's the idea of using things like causality. So the idea that one thing happened and then that caused this thing to happen, that caused this thing to happen, that caused this thing to happen, which is very, very different to using logs. So if you are doing logging and doing structured logging, you are, a lot of the time we get this, well, traces are just, spans are just like structured logs, aren't they? The idea of tracing is the idea of causality. That this HTTP request that came into service 1 then went through these lines of code that did this. Those 3 lines of code then went off to call this service over here, and then this service did this with this and this, and that went to a database, and that went to a Redis cache. And it's about that causality. Now, you can have lots of log lines that tell you all those things. That causality is really, really important when you're talking about high-load systems. It's important to note as well that distributed tracing is not a tool. It's not something that exists that you buy. It's not something that you can just implement. There are libraries that do tracing, but tracing itself is a concept, not a library. Speaking of libraries, what is OpenTelemetry? So OpenTelemetry is the #2 project on the CNCF projects. It's a language agnostic, protocol first idea of how do we look at different systems that are in different languages and provide that distributed tracing over all of these different things. It's built on top of the W3C's trace standards. So it is based in an actual standard, but it's an initiative that came together from 2 competing initiatives called OpenSensus and OpenTracing. They came together and went, well, how about we work together and make one thing that everybody uses? It's now being adopted. With it being #2 in the list, you can imagine that it is being adopted very, very widely. And I didn't remove that last term point on that slide. So yeah, bullets, roboto, regular, it does that as well. What is a trace when we talk about OpenTelemetry? So the trace is the thing being done. So if you think about a HTTP request, your trace is from your outside of your request, and everything that happens within there. That conceptually is a trace. It's the thing that's being done. You can format a trace however you want. You could say that I only want traces on this system over here, or I only want traces on this system here, and I don't want any traces for the thing above. I generally don't subscribe to that methodology, but a trace is conceptually the thing that's being done. It consists of a few things. So we've got things like child spans, which are little spans within there. So a trace in itself is just a span that doesn't have a root to it. You can see some bits of information on the side there, the kind of things that it would encompass. It encompasses something called baggage, which we'll come to, which is the footgun that you never thought you wanted. And it also has things called tags or attributes, which are all the different bits of information around each of those spans that's being created. So, OpenTelemetry and .NET Core, or ASP.NET Core. We're going to focus on ASP.NET Core. The stories around console logging and various other bits is not as fully fledged as it is in ASP.NET Core. ASP.NET Core, the implementation right now, is still in release candidate. I think it's 9.3. I think we're adopting the Microsoft versioning methodology. So we'll be at RC 9.3 pre-alpha 7.7 RTM soon, I'm sure. It is being used in production by some very, very large companies, so I wouldn't let that put you off in using it. But it is marked as an RC at the moment. When we get to full, I don't know. But there is a lot of talk about that being very, very soon. So the first thing we're going to have to do is talk about something called activity. Now, this is one of the most annoying things around OpenTelemetry right now, because OpenTelemetry uses terminology called spans and traces and attributes and baggage and various other bits. Microsoft, in their infinite wisdom, said, no, we don't want that. We didn't invent that. So we're going to use something called activity, which already existed. Props to them for that. They use something that already existed. It exists in the BCL. So you'll see a lot of mention when you're looking at the tracing libraries on the SDKs that are in the different languages, that the terminology doesn't match with ASP.NET and .NET. That is an annoyance and a complication. Once you get your head around it, it is really easy to understand. My recommendation is, if you are writing libraries, if you are writing open source libraries, if you are writing shared libraries to be used inside your organization using the inner source method, I would advise that you use activity. The reason is that that means that you're not bringing in an external dependency on OpenTelemetry, which brings a hard dependency on an external library. The idea of OpenTelemetry gives you things like propagation, so the idea that you can propagate a context from one service to another. It gives you other things around this transition. Those are really useful when you're writing an application, when you're actually writing your first-party service that's going to call out to other things. That's really useful. It's not as useful when you're writing a library to abstract away your Cosmos DB usage. It's not as useful in that context. Now, if you are writing those libraries, then try to think about things like, is this span enabled? One of the other annoying things is when you try and create a span, which we'll look at in the moment, you have to check whether it's null. Because if it's not observed, then it's null. Which means that you get problems in your code if somebody doesn't observe the thing that you're trying to emit, which is really annoying. But these are all things that have been worked through. So, like I say, Microsoft decided to use activity. All the demos that we're going to be talking about today are using activity. It is the sort of the concepts that's in the OpenTelemetry docs. So that's what we're going to be using to go through. They work the same. You can use your application. In your application, you can use activity. You can use the OpenTelemetry SDKs and bring those in as well. It's entirely up to you which one you want to do. So, how easy is it? I said it's very, very easy, about 10 lines of code. 3 packages. You can actually do it without the 3 packages if you really want. You don't need all of them. But what we're doing there is we're bringing in the hosting package. So the way that OpenTelemetry works, we will get some traces, some spans. Those spans will go into an in-memory buffer internally. And on a regular basis, it will flush those out to a third party or first party if you're using something like Jaegar. So that's what our hosting package does, which is then going to be doing this flushing periodically of these spans that have been created. We've got an instrumentation for ASP.NET Core. Now, everything that we're doing, we need to instrument. We need to say, this is the thing that we want to monitor. The instrumentation libraries these are auto-instrumentation libraries. They're written by Microsoft. The ASP.NET one is co-authored by Microsoft, which says that these are the things within ASP.NET Core that I would like to emit. You have some options that you can turn on and off in there, but we're saying that we'd like to know what the HTTP request route was. We'd like to know what the user agent was on that request. They're creating these spans for us. Bringing in these libraries allows us to just go, yes, I'd like all those, please. Send them over to my tracing provider. It's fine. We've also got the one for HTTP. So that's the HTTP client. Allows you to do a lot of things around the request handlers and things like that around HTTP client. These are all libraries that are available to you. There are things like the SQL client. So if you bring the SQL client in, that's going to instrument things like the command text that you send over, the parameters that you've sent in there, all things that you can then report on in whatever tool you use to receive these traces on the other end. But there's a lot of these that are auto-instrumented. My caution would be, auto-instrumentation will get you so far. It is step 1. It is not step end. Implement these libraries, go home. These are the first step. They will give you a level of visibility. Normally, you'll get these things and you'll go, wow. We call it the MTT WTF, the mean time to what the was that? Because these auto-instrumentation libraries are going to give you a level of information that you didn't think you needed. Because they will tell you things like, it's one user. It's one user that's causing all of these problems in my graphs on Grafana. Wow, this is really important information. But that's step 1. The next step is then going, what's interesting about my application? Why is my application interesting? I've got an algorithm that I'm going to run inside of my application. So I want to wrap that, and I want that to be a span. I want the inputs into that algorithm to be output for me to be able to report, to say that algorithm runs slow on a Tuesday when the data center is 72 degrees because I've attached that as an attribute. Don't do that. But these are the things that you now get to your next level of saying, these are what's interesting about my application, because every application is different. So then how do we then set it up? I would imagine everybody here is using at least .NET Core, possibly even minimal APIs. This is minimal APIs, if you've not seen them. They are really, really cool, especially if you're writing microservices. It is simple. It is add OpenTelemetry tracing, tell it which one of the instrumentations you want, and then tell it where you want to put that information. So OpenTelemetry has this idea of the instrumentation, the spans, but it also has this idea of exporters. And exporters are where are you going to send all of these spans that you create? Where are you going to send them to actually visualize them? And we'll come on to two of those at the end. Obviously, I am going to talk about Honeycomb, but I'm also going to talk about the open source solutions in Jaegar. Zipkin still exists, but Jaegar is predominantly the one that people use. So we'll talk about that one as well. So you'll see on this next one, we've just replaced that console exporter with the Jaegar exporter. You can have both of them in there. You can have 10 of them in there. You can have as many of those exporters as you want, and it will send all of your traces to all of those exporters. That's what we normally suggest to people if they are trying out different providers, to send it to both of us and see what the difference is. Because different providers, different exporters, provide different value. Some people focus on service mapping. Some people focus on high performance and high cardinality. All of them focus on different things. And it's up to you what's important to you to know what to do. You can add as many exporters as you want. Just bear in mind, if you're batching things up, the more you batch things up, the more exporters you add, the more memory you're going to use. So just bear that one in mind. So, child spans. So I talked about what is part of a trace. A trace is an entity. It has child actions that are part of it. So if we're talking about a distributed system, you've got your HTTP request that comes in at the top. You've got all the different microservices that then end up being part of that. If you're writing the sort of distributed monolith type methodology, you've got lots of HTTP requests going everywhere. If you've got messaging, you've got messages going everywhere and loads of things coming back. Those are all child traces. Now, what I want to make clear, though, is distributed tracing doesn't have to be about microservices. You can wrap inside of your code like this a particular action. So I talked before about the algorithm. You may have an algorithm in your code that you want to wrap around and say, I'm going to create a little child span for that particular thing. And we'll show something like that in the demo. So a child span is just creating an activity from a source. So you can see on this diagram here, we're creating an activity source, which in OpenTelemetry terms would be a tracer. And then we're going to create an activity off the back of there. So we're going to create a span off the back of there. Now, I've not done anything with that span. All I've said is that a span has a time limit. So what I've done is I've wrapped it in disposable. So that delay is going to come up as 500 milliseconds. Nothing special on there. We can do a few more bits with that, though. So that's what a child span would look like. It doesn't match 500 milliseconds, but that was probably me changing the demo. So that second delayed process that you can see there, that's a child span that's happening inside the application. And you can see that we've got causality. I talked before about the idea that tracing is about causality. Now you can see from that diagram that we've got the delayed process is caused by that one above it. It's not just two log lines. It's actually caused by that one thing. They're part of the same thing. If we had 10 to 15 of these in a distributed hierarchy, then you would be able to see what one request has caused throughout all of your systems. Our system that we build has a limit of about 5,000 spans that you can have on one screen. If you get that large and you need some help, come talk to me, because I need to know what you're doing. So, now we'll talk about attributes. So attributes are these extra things that you want to know about that span, about that trace that's coming up. So you can set arbitrary information on it. You can say, I don't know, account type is what we might put in there. Oh, I want to tag all of my traces so I've got the VIPs. So I can actually monitor the VIPs separately to other things. That might be something that's really important to you. It might be your account IDs. It might be the number of things inside of your algorithm that you're analyzing each time, which would allow you to know, well, when it's 100 things that I'm analyzing, the performance is this, whereas when it's 200 things, it's this, when it's 500 things, it's this. These are all things about when I was talking about that intentionality, about you thinking about what should I be emitting from my application. This is you saying, this is important to me. Now, what you should be doing there is putting everything that you think might be relevant. Not just the things that you know about right now that you think are relevant, put everything in there. And this is that idea of when I go into production, I don't know what I didn't want. It might be the temperature in the data center is actually really important. Who knows? If somebody works out how to actually do that, I want to do it in a demo. So if you can find the temperature in a data center and stick it in a span, do let me know. Okay, so what we do there is we're focusing then on the information that comes in. Now there's two terminologies that we use. It's called high cardinality and high dimensionality. So dimensionality is about the number of attributes or tags that you add to each one of your spans. You should be adding as many as you can onto there. High cardinality is about providing in there information that can have millions of possible values. So think about account ID. Now, if you've used something like Prometheus, and you've tried to put account ID on there to try and map things, I can see the people smiling at the ones that saw Prometheus rocking in a corner, just going, please don't. That's about high cardinality. Metric systems really struggle with it. Tracing systems do not. And that's why you should be putting those things in there, because in high-load systems, you do want to know what proportion of your users are affected. Is it 1 user? Is it 5 users? It might be user groups in there. You might want to put 50 user groups in there. And all those things are really useful to be putting in. Okay, so now I'm going to talk about the foot gun, which is called baggage. I wrote a blog post about this because it really annoys me. Baggage can get you into a lot of trouble. Now, baggage was a W3C standard, which is why it was implemented. And it's the idea of passing context between two services, which sounds simple. You know, just put something on one service, and then when I go into the other service, I'd like to know what that thing was. Maybe it's the account ID is only available when I do the claims on the request at the front. I want to be able to put it on my spans off the second application. Sounds awesome. It sounds simple. Now, the problem with that, though, is there's this little phrase here that people forget. And it says you shouldn't put confidential information in there. And the reason is because it can transition boundaries outside of your application. Now, we talked before about the HTTP client implementation. If we've got two services, we've got our service that's our front end, we've got our product service where we go and get product information to render on our service. Great. On the product service, we can say how many individual users have been getting an individual product. Really great information. The problem is our front-end service also goes off to this currency exchange service and gets the exchange rate. And guess what information it puts on all of those requests, because it's HTTP client. All of your confidential information goes on all of those requests because there is no whitelist. It doesn't know what's an internal service, what's an external service. It just puts all of that information on there. So for that reason, to me, it is incredibly dangerous. Now, it's also just some arbitrary information. It's an arbitrary string. I saw somebody recently serialize an object into JSON, base64 encode it, and stick it on baggage. Anybody heard of view state before? That went so well, didn't it? But that's what people are doing with these things, because it's just a string. And they say, well, I want that object in this other service. I'll just use baggage. That's the bad side of it. That is what makes it very, very bad. It is, however, really, really powerful, because it allows you to, in a language-agnostic way, describe things that should be on other services. So I talked about account ID. And account ID is a really important thing that you might want to use on your product service to say, this particular high-value product was coming through and we keep getting hammered on our product service. Is it one user that's causing that? Is it some bug in our system? It might be, oh, it's the VIP users are always slow. Oh, it's only the normal users. It's fine. We don't care about those. But this idea of being able to transfer it in a language-agnostic way, which means that if your third-party service or your first-party service that you're using is written in Node, God forbid, then yes, it can extract that information from baggage, even if it's coming from a .NET service or a Java service or a Go service or a Python service or a PHP service. All of those have SDKs for OpenTelemetry. And baggage provides a language agnostic way for you to say, here it is, account ID. You can go and get account ID and you can put it on your spans. One thing to mention is baggage is not another type of attribute. So we talked before about our attributes that we were adding to it. And we were putting our type of awesome thing on there. Just by us saying that we're going to add baggage doesn't mean that that's an attribute that will go onto your tracing provider. Baggage is a different concept. So how do I add baggage? It's really, really, really complicated. You call the baggage set baggage. So if you want to see that in a little bit of a wider context, I'm not expecting everybody to read that. It's actually quite big. So what we're doing there is we are setting our baggage, and then we are going to call an external service. And this service that we're going to call, this product info service, is going to get that baggage information over, which is our account ID, that it'll be able to extract. And you can see there we've got child activity within a child activity, and you can go as deep as you want to do. So that's the baggage stuff. I like it, and I think you should use it. Just be really, really cautious about what you do. Think about the external services that you're doing. You can clear the request before you do it. So if you're using HTTP client, if it's going to be an external one, go into your HTTP client, clear all the headers, make sure you don't pass the trace IDs. There is an amazing story that, if you come and grab me afterwards, I'll tell you when that went wrong as a provider that receives traces. It's a very interesting and funny story that I won't tell live. But yes, that is the baggage stuff. Now, I'm intentionally not going into a lot of depth here. This is meant to be everybody should be using OpenTelemetry. Go and use OpenTelemetry. There is no downside to you implementing OpenTelemetry. All of the providers, all of those external providers, the Datadog, New Relic, Elastic, everyone, all the big providers that do APM solutions, all of them are moving towards OpenTelemetry as being their protocol. So you should be doing that. What I'm trying to do here is say how easy it is to get that basic level of observability. But you should go further. You should start to think about all the extra bits that you can do, all the manual instrumentation. So I'm going to do a bit of a demo. Now, this I talked about before, that causality. This thing here is our product, Honeycomb, which shows you that we've got something here that's going to call and get some account information. It's going to call and get some product information over a second service, and you can see that we're visualizing the different service names in there. So, and I'm going to actually show this live, if it works. Wish me luck. So, there we go. So what I've got here is just two basic services in .NET. They're using minimal APIs. So we've got, on the left is our service one with a few different routes on it doing some different things. Can the people at the back, can you read that all right? Do you want me to zoom in? Zoom. Okay, no. So we'll open it one by one then. All right, how's that? Good. Okay, so service one, we're doing what we said before. We're going to add our extra source. So we talked about activity source. We create an activity source that allows us to separate some of our methods. Now what we need to do is tell OpenTelemetry to listen to that source. Because it's emitted as part of activity, an activity source, we need to tell OpenTelemetry when it runs, go and listen to that thing. What we're also going to do, as I said before, we're going to add two exporters. We're going to add our Jaegar exporter, and we're going to add our Honeycomb exporter. I wonder if I've got the console exporter, if that works as well. I don't have it, but you could add more exporters in there if you wanted to. So this is our front-end service. We've got basic route. This is on GitHub, by the way, so you can take this away and use it. Entirely up to you, at your own risk. If it burns down your data center, it was not me. So our first one here is our child span. We're going to add our account ID as baggage onto there. The more complicated one is this one. This is our showing of baggage. And I'm going to show this one as an example of how we can do it. Because It's the more advanced one. So what we're going to do here, we're going to go and get our HTTP client, which is going to set our base address to our other service. We're going to create a dummy account ID because I'm not going to write an account service as well. And we're going to create a child activity. Now, this one here between lines 52 and 58, that would be where I would see something like an internal algorithm that you're wanting to do. You just want to wrap that thing. You want to add some information to it. We've gone and got some account information, that kind of stuff. The second one is our product. And what we've got inside of here now is two different child activities. They're not causality of each other. So our baggage causes an account activity. But our account activity doesn't cause a product activity. That's up to you to decide what's important to you in an application. And this is where I talk about this intentionality, because you know what's important and you know what you want to see. Our product activity is going to set a tag on our product activity span, and it's going to call out to a product info service, which is then going to return us some information about a product. Okay, our second service is even simpler. So our second service, we're going to do the same thing. We're going to set up our Jaegar exporter and our Honeycomb exporter. You'll notice on here it doesn't have an activity source. And that's because we're not creating any internal spans in this one. All we're going to use is the standard ASP.NET spans. And you can see here what we're doing is we're using the current activity, which is a thread-safe way to get the current activity that is active inside of your application. And we're just going to tack some more attributes onto it, because we don't care about creating another subspan. And then we're just going to return that information. Like I say, incredibly simple. So, we're going to run that, if I get into the right directory. And you know this isn't going to work now because, you know, I didn't do the ritual sacrifices before I came on the door. Okay, so we've got our baggage endpoint. This is our service one that we're doing. We're just going to hit that. You can see it's taking a little bit of time. The reason is because I put some delays in, so it makes our span look good. So we're going to do a couple of those. Now, I'm going to show Jaegar first. So Jaegar, what I've done here, I've run this up locally in a container. It's one line. It's not hard. You should be able to do this. If you've got Docker Desktop, I would advise that you start doing this locally just so that you can start to see it. There are some initiatives around how do we visualize traces without external applications. So particularly putting things like graphical analyzers on the console. But at the moment, the only way to visualize your traces, especially in .NET, is to have something like Jaegar or some other third-party product like us, which we do have a free tier, by the way, that you can all use. So that's my wages covered now. So you need something else to visualize them. So you can see here, this is our trace of our front-end service. Let's zoom in a little bit here. So you can see we've got that causality. So what we've got there is our first top-level service is our call to account. We've then got our second bit, which is our running of getting that account information, which is just our dummy 500 millisecond rule. And then we've got our get onto that other service. So you can see front-end service and product service are the two different things. And if we zoom out a little bit, you can start to see our traces, our waterfall chart. And these are the things that you would know if you've been doing tracing, if you've been doing things like continuous profiling with APM tools, you'll be used to this kind of stuff. But this is about you being intentional about what you do, rather than this being all automatic. And it's also vendor agnostic, so that you can switch provider whenever you want. And it's something that we advocate for, because if we're not the best, move on. So, but we can see there we've got our different 500 milliseconds is around that. So what we're adding about 9 milliseconds onto the ASP.NET is what's adding onto our calls. Then we can start to drill in and start to see some of the tags that have been added. So those ones there, those are the default ones that I was talking about. So when we do ASP.NET Core instrumentation, we say, just give us everything. That's the information it's going to give us. Now these are standard attributes. So HTTP host, HTTP method, these are standardized in the OpenTelemetry specs. There is a semantic naming that they talk about. So if you're using Azure, there's a load of Azure attributes that start with Azure dot. There's AWS for AWS dot. Apparently there's some googly thing that has its own. But you've also got things like the OpenTelemetry library. So what library version am I doing? And these are all really interesting things that you might want to know. What's the assembly version of my libraries? Because it could be that you've got some old code running in your application. You've done a Kubernetes deployment. It's done a rolling deployment. You've got one stuck pod living there. So you might want to put all those things out there. And then we've got all our honeycomb attributes as well. And now we can start to get to the stuff that we've added ourselves. So you can see there we've got that account type thing that I added in there. Now, when we're going to get down to this bottom one here, which is the span for our product service, you can also see that we've got account ID. Now, the product service request didn't get account ID. All it got was the account number, the product ID. It didn't get an account number. But what we did is we passed that over in baggage because, you know, we like to live life dangerously. So we've put that in there. And what we've done with that, if we go back to the code, if you look at this line here, we go and get the baggage. So we get a known parameter of account ID out of baggage, and then we set that as an attribute. That's the thing that catches almost every person I speak to out. They say, I've added my baggage, but all of my child spans don't have that attribute. And that's because that isn't what baggage is. Baggage is an ability to send the context between services. It's not the ability to add it to spans. There are solutions out there that will take all of those baggage things and apply them as span attributes. I don't advise using them. Some people do. I do not. It is dangerous because those things that come in, those baggage things, could come in from external services. So if you've got a publicly available service, what if somebody sends over to you a load of baggage attributes? Are you just going to take all those and apply them to all of your spans? Is that useful? Probably not. In Go is the only language right now that has the ability to say, I'm a public endpoint, ignore all of the baggage. We will get one in .NET soon, but it isn't there at the moment. So that's our Jaeger exporter, and you can see we've got product ID, that one's coming through as an integer. We've got account ID, it's coming through as a GUID. I mean, this is all basic stuff. But now we can start doing some interesting stuff with that data. Because we've got this stuff in our Jaeger stuff, we can start to do some searching on, well, let's just find all of the account info ones. Anything that contains an account info attribute. Now, my issue with Jaeger is it's hard to scale. It uses Cassandra under the hood. If you want to try and run this internally, then you're going to have to start thinking about how you scale Cassandra when you start to think about thousands and thousands and millions of traces. It is very, very good for doing this basic level of stuff. And if you've got some small value services, some small services that you're running, absolutely Jaeger will be providing you much better than just a logging solution. Just taking something, throwing it through FluentBit, and then displaying some log attributes. You're going to get a lot more information by doing this because you're going to get that causality. Now, if we look at those same things on our service, if you want to go, that's fine. This is what we do. It is much better, but I am ever so slightly biased. So what we've got here is the same sort of trace that we've got on there, which, you know, it's exactly the same thing that you've got, other than the fact that we've now got some more information down the side. And this is where we say that OpenTelemetry isn't special. It's not special, your exporters. They get the same information. It's all about what you do with them. Now, for us, we focus on the high cardinality attributes. So things like user IDs, high performance, that's our focus, so that you can start to see things like the heat maps of your requests, which is not going to be very big on this one, but we can start to do things like a heat map on your duration to see where where are all the requests going that are quite, I mean, there's only 2 requests there, so you can't really see much in there. But you can start to see a lot more information through these exporters. But you can send it to all of the exporters. You can send it to one exporter. You can start to trade off different exporters to see which one is the one that's going to provide you with the best information. Okay. So we've looked at Honeycomb, we've looked at Jaegar as outputs, as exporters, as that terminology. Now, the other thing that you can do is, especially if you're using high volume systems, if you've got 50, 70, 100, God forbid, 1,500 microservices in your application, managing the keys to send to different places is going to be quite hard. You've got if you have a key that expires, you've got 1,500 deployments to go and change all that information to change your external stuff. Now, OpenTelemetry has something called a collector. A collector is an exporter, the same as Jaegar, the same as we are, but it's more of an aggregator. So it will take all of your span data in and allow you to do something central with it. Now, that might just be send it all here and we'll send it out. That's really useful if you've got a constrained environment, a secure environment, where what you need to do is send all of your data out through one egress endpoint. So you've got my services can't talk to external services. So what I need to do is I need to send them to something else. That something else can talk to one endpoint, and that might be your provider that you're sending out. It might be to your Jaegar instance. That's really useful in hypersecure environments. It's also useful if you've got a third party that has keys, because you can change your keys in one or multiple locations in your collector and only in your collector. There's also some really interesting things inside the collector because it can do post-processing on your spans. Now, if you're in an environment which you might be outputting personal information, or you might be handling some personal information, it can be really useful from in one specific location to say, anytime you see something that's a 16-digit number, probably want to remove that, because that's something, before I send it on to my third-party provider, I don't want them to get the credit cards. So you can provide these redaction filters. There's a redaction processor that you can put in that says, search for something that looks like this. It might be an attribute called first name. Remove that. We don't want it. I still want you to send all this other information up, but remove these bits of information. From a security context, it's quite useful to be able to do that sort of stuff. You can also do, in some of the languages, and I said before in .NET, it's not a particular problem in .NET, where we put things into a background process, and then in that background process, we will then send that information over to a third party asynchronously. So it doesn't actually affect your request. There are languages that don't do that. There are languages where it will send out that information synchronously. So if your third-party provider has a blip and it takes them 10 seconds to receive that information, your HTTP request now takes whatever you were doing plus 10 seconds, which is not great. The collector allows you to say, in my application, I'm just going to send my information straight to this collector, and the collector will handle all those retries, all of that offline stuff. Now, one place that it's particularly useful is in Azure Functions, because Azure Functions doesn't have a background process for you to be able to send that information into, and that background process to be able to run. It's a lot better in our process functions, but it is still a problem. So using something like the collector, you can co-host that in a location close to your functions and be able to synchronously send all of your spans to that collector and have that push that information out to wherever it needs to go, whether it's Jaegar or third-party providers. Now, it also provides this really interesting capability for centralized enrichment. So in a Kubernetes environment, you might want to say, I'd like to tag everything with the namespace. All these spans that come over, I want to tag it with the namespace. I want to tag it with a pod ID. I want to tag it with the region that these things are in. Now, what this allows you to do, because you're sending it through the collector now, you don't have to worry about that in your application. So in your application, you don't have to worry about the tags that you're going to add. You don't have to worry about, am I hosted in Kubernetes? Am I hosted in a container apps? Am I hosted in something else? Using a collector, it can say, oh, you came from a container app. You came from a pod in Kubernetes. I'm going to work out what the details of that pod are, and I'm going to do that enrichment. which again is a very, very interesting use case for the collector. Once you get to a significant size, I would always recommend you use the collector instead of going direct. So if you're using something that's incredibly high volume, go through the collector. If you're using something that's got more than, say, 2 or 3 microservices that all need that same key to go to that same external service, put a collector in. It's very, very lightweight. It can run as a container. It can run as an application. You can run it as sidecars inside of Kubernetes. Now, the one thing I haven't got a slide on at the moment, because it's only in beta at the moment, is something called the OpenTelemetry agent for .NET. Now, I don't agree with the concept. I will be open with that because it's about auto-instrumentation rather than being intentional. But this allows you, in the worlds, if you've been doing tracing, doing APM tools in the past, where you would install an agent on your VM, put it next to your .NET application and say, instrument this .NET application and give me all of the information. There is now an OpenTelemetry agent for .NET that you can run as a sidecar container in Kubernetes and point that to your application and get all of that auto-instrumentation that we were talking about. It will go in and find all of that information. It's only in beta at the moment. It might even be in alpha. It is very, very new. But it does allow you to say, if you're somebody who doesn't have the ability to change the code, then you can apply this collector, this agent, and get that agent to then send those to the collector, and then the collector can then forward those up. And you get a nice open source, vendor agnostic solution for taking tracing and span data and sending that elsewhere. So that's me. I am happy to take some questions. I managed to get at least 45 minutes out of about 10 lines of code, which I think is pretty impressive. But I'm more than happy to take any questions, or if you want to come and see me, come and have a chat. We do, at Honeycomb, do observability office hours. So if you go onto our website, if you've got some specific questions, some problems, that kind of stuff, by all means come to us. It doesn't have to be about what we're doing. We are what we consider to be the observability experts, because we've been doing this for the longest in terms of observability. But by all means, book some time with us and we can happily go through some specific use cases with you. Oh, 2 questions. Do you want to shout and I'll repeat? I'll go with you first.
I didn't use tracing or OpenTelemetry tracing, but I used logging and metrics OpenTelemetry. And they're really nice, and I could export to a console, so it's fine. The thing is, do you recommend to do that because it's not generally available yet? Just the tracing is generally available as far as I know from OpenTelemetry. Do you suggest that we start using logging and metrics as well, or should we wait for it?
Okay, so the question was, in OpenTelemetry, we have traces. Traces are a first-class citizen. We've also metrics has just gone live. So metrics is part of the OpenTelemetry spec at the moment. It's not GA inside of the .NET SDKs at the moment. But there is also an initiative called OpenTelemetry Logs, which is the idea of standardizing the protocol of how logs get sent to vendors. .NET Crowd, so pretty much everybody's heard of Serilog, and Serilog has multiple different syncs that allow you to send it to various different locations. Each one of those syncs is specific to a vendor. OpenTelemetry Logs is the idea of how do we standardize logs. We've standardized how we send traces, we've standardized how we send metrics, and now we're about to standardize how we do logs. Logs in .NET is not fully fledged at the moment. I would not recommend using it yet. We're only a few months away though, so keep checking the sites. The protocol, so the idea of what the schema is when it gets sent to a vendor, that stuff has all been finalized. It was finalized last month, I think it was, just as KubeCon happened where we did the project meetings. So the protocol has, and now all of the SDKs need to implement it, and then the vendors need to implement the protocol as well. We're not far off. I wouldn't recommend logs just yet, but it's not far off. Cool. So building a service map. So the idea is, the question is, within Honeycomb specifically, do we have the ability to do a service map? Yes, it is coming. It's not there yet. Very, very close. I would love to show it, but the engineering team would kill me. And I do like my job.
Yes, I'd like to
Oh, sorry.
Yes, what is the relationship between tracing and logging? Because they seem like they fulfill kind of the same space, but not entirely.
So the big difference, and this is something that, so the question was, how do spans and traces relate to logging, because they seem to solve a similar space of problem. The big difference between spans, which would be the equivalent of structured logs, is causality. So the idea of a span is that it is descendant from something else. So in a span, the core three attributes you have are the trace ID, the current span ID, so the unique ID of this span, but also the parent ID of that span. So which one caused me to happen? And that's the big difference with tracing, is the ability to say this particular entry was caused by this one, but it's part of this larger thing. We've had in logging the ability to put correlation IDs in, for instance, for a while. The causation stuff is the stuff that isn't really in the logging space at the moment. Obviously, you can do this in structured logs. The idea of a span is just a JSON blob with attributes on it. You could absolutely have created this in the past with just saying my structured log has this parent span ID, this parent and this trace ID. You could absolutely have done that. But that idea of saying that this is how a span works, this standardization of a span, it has to have these bits of information. It has to have a context. It has to have a duration. All of these things are making that a subset of structured logs, if you want, because it's about saying that all of these providers, all of these exporters take this in a particular way.
Do you think this is better than structured logging, or do you still need both?
1000% get rid of logs, they can get in the bin. So yes, I believe that we should be killing logs. I don't believe logs in the context of where we're moving with microservices, where we're looking at high volume systems, where the only place that you will see the actual usage of your application is in production. Logs do not give you that. Logs can give you a lot of stuff when you run locally, because you've got one request going through. It's you doing your request, and you can see those logs. When you're in a production system, logs just don't give you that. I'm looking at a log between 17 different services to work out where the problem is, and I'm trying to grab all of those logs and send them to one place. That not only takes time, because I've got to send all of these traces to one location, I've got to throw them through an ELK stack to then aggregate this information up, I've got to throw them through any kind of number of processing pipelines, it takes time to get those things up. The idea of traces is that already exists. So to me, yes, you shouldn't be using logs really anymore, but they do provide some benefit. We call them observability light, because they will give you some of the observability. They will allow you to do some things, but they're not as good as tracing is. Tracing is going to give you that causality. It's going to give you the ability to look at a production system and see that information coming out of it. Does that answer your question? Awesome. Any more questions? Mark, hello. You can make it do that. I generally would not recommend it for that kind of stuff when you're putting a stack trace in there. So the question was, if I throw an exception in my code and it's an unhandled exception, can I have that inside of my stack trace, inside of my span? You can. There is an attribute on the ASP.NET Core instrumentation for record exception, which will record all of that exception data in there. It becomes less useful when you're trying to do things like heuristics on that logging information, the exceptions. There are better tools out there than a lot of the observability vendors for doing tracing. Because when you get an exception, what you want to be able to do is have a look at that stack trace and find some commonalities with other stack traces that might have happened. That stuff is beyond the capabilities of tracing at the moment. Also, there are some providers that do it, but it is an extra bit on top of that. So yes, you can. How useful that is, it's entirely up to you. But this is all what I tell you about the intentionality of what you're doing. If you're going to put it on there, you need to be actually using it. You need to be thinking about this will be useful at some point, or it might be useful. Any more?
how mature is OpenTelemetry and the .NET implementation regarding that?
So the question was around user telemetry. So the terminology for that is real user monitoring, or RUM. There is a project ongoing in OpenTelemetry to bring in a RUM project, which is apparently starting next month. So they've got a special interest group that's forming to think about how do we standardize on RUM now. We've done tracing, we've done metrics, we've done logs. Now what do we do around real user monitoring? So how do we look at the tracing of a front-end application to work out user sessions? Because is a session a trace when a session could be 4 hours long? That's not really the same sort of thing. So there's a whole committee that's forming around that same thing. It's all about telemetry. How do we get to that point where we've got a standardized approach to real user monitoring now so that the vendors can be then standardizing around that thing? So at the moment, there isn't really a story for it. Any more questions? Awesome. Right. Well, thank you very much for coming, and I hope you all got at least something out of this, but main takeaway for me, go and use OpenTelemetry, and then whichever vendor you use it through OpenTelemetry.